Imagine a flying skyscraper that weighs like hundreds of cars, costs like a whole neighborhood of business jets, and can still haul cargo that won't fit into any other airplane on the planet. This is the Antonov An-225 Mriya. Until 2022, it was the largest aircraft in history, built for one purpose: to lift into the sky what the rest of humanity had already labeled too big. Its length is roughly 275 feet. If you're standing by the nose on the ground, you simply won't see the tail. Its wingspan is about 290 feet, wider than an American football field with both end zones. Maximum takeoff weight is up to 1.4 million pounds, around 640 metric tons. That's like taking about 160 ordinary cars, compressing them into one giant object and telling it, now you're an airplane, fly. Today, we're going to break this dream machine down the way you'd break down a luxury supercar: how much it weighed, how it even took off, what it carried, and why its ending cost not only money, but an entire era. Welcome to the channel for the richest.
Luxury life.
The Colossus that's bigger than any other airplane. From below, Mriya looks like a building that someone accidentally put on wheels. The fuselage stretches to 275 feet, longer than the wingspan of a Boeing 747. To lift that kind of mass, engineers had to build a wing with an area of about 9,740 square feet of metal that literally clings to the air to hold up the impossible. For people used to private Gulfstream and global jets, this isn't an airplane, it's a flying industrial plant. When the wings are too big to see them all at once, size creates not only awe, but brutally expensive problems. From the cockpit, the pilots can't see the wingtips at all. Each wing extends 145 feet to the side, like a 10-story building shifted sideways away from you, and all of it has to fit on a normal concrete taxiway. The solution is to raise the cockpit high up on the nose, almost like the captain's bridge on a super yacht. The pilots sit above the deck level just to get some control over the edges of the taxiway, but even that isn't enough. That's why every time Mriya rolls out of its parking spot, it becomes a mini operation. Alongside it walk wing walkers, people on the ground who watch whether those gigantic wing consoles are about to clip a terminal, a light pole, or some other piece of airport infrastructure. No camera gives you the same depth of information as those few people, whose decisions can sometimes determine the fate of an aircraft worth hundreds of millions. The twin tail. When a plane carries another ship on its back, you recognize ordinary airliners by a single vertical fin in the rear. On the An-225, everything is different. At the back stand two vertical surfaces, each roughly 60 feet high, mounted at the ends of a massive horizontal stabilizer. Why? Because this aircraft was never built as just a freighter. It was entrusted with another luxury of Soviet space ambition: the Buran spaceplane. And that shuttle had to be carried directly on the plane's back. A single conventional vertical fin would have been blocked by the external cargo and would stop working properly. So the engineers split the tail into two towers on the sides. That way, control remains effective even if you've got an entire spaceplane parked on top, about 118 feet long. That's a level of engineering tuning that even owners of the wildest hypercars can barely imagine. 6 engines strong enough to lift a small house. Under Mriya's wings hang 6 engines, 3 on each side. Each one is a huge D18T turbofan producing about 51,600 pounds of thrust, roughly 230 kilonewtons. That's about what one engine on a Boeing 777 makes. All 6 monsters together generate around 309,600 pounds of thrust, about 1,377 kilonewtons. For comparison, a classic Boeing 747 produces roughly 266,000 pounds. The An-225 is about 16% more powerful, and it uses that power not for speed, but for the ability to lift a monstrous weight. But the real magic isn't in the numbers, it's in how they do it. A huge airflow enters the engine's intake, and about 85% of that air doesn't burn at all. It's simply accelerated by the giant fan and blasted backward, creating thrust. Simplified, it's like a massive room fan with a diameter of about 7.5 feet spinning at insane speed, only wrapped in metal and fed by jet fuel. Only the remaining 15% of the air goes through the fire heart of the engine, where it's compressed through 14 compressor stages to a pressure about 24 times higher than normal atmospheric pressure. Then fuel and air become a torch at roughly 2,900 degrees Fahrenheit, spinning the turbine and, once again, that giant front fan. 6 such systems run at the same time. This isn't just an airplane, it's a mobile power station with wings. Fuel appetite, when one flight is like several pools of kerosene. That kind of power is expensive, literally. Mriya's fuel tanks held about 96,000 US gallons, around 363,000 liters of jet fuel. That's almost 5 average private pools filled to the brim with aviation fuel. At cruise altitude, the 6 engines drink about 4,200 gallons, roughly 15,900 liters per hour. Picture it, every 60 minutes, volumes disappear that could fuel about 280 passenger cars. And all of it is just to keep this flying skyscraper from falling out of the sky. If the aircraft wasn't fully loaded, those reserves could last about 18 hours of flight and around 8,300 miles of range. But fill the cargo hold to the limit and the range drops to roughly 2,160 miles. Still a lot, but for intercontinental missions, you have to plan refueling like private jets hopping halfway around the world. Every extra kilogram of cargo means fewer kilometers of range. In the world of ultra-expensive aviation, the equation is simple. Want to carry more? Pay in fuel, time, or money. The birth of Mriya. When a country needs its own space limousine. This monster didn't appear by accident. In the early 80s, the Soviet Union needed its answer to the American space shuttle. Buran was born, and with it came a problem. How do you deliver a space plane from the factory to the Baikonur Cosmodrome? The designers already had the An-124, a giant as well, the largest military transport of its time. But even it couldn't carry Buran on top the way the American Boeing 747 carried the shuttle. So the Antonov Design Bureau took the An-124 and scaled everything up. They lengthened the fuselage by about 23 feet. They stretched the wings by another 49 feet. 4 engines became 6. In December of 1988, the new giant lifted off for the first time, and 3 months later, it was already carrying Buran on its back to the air show in Paris. Back then, it looked like a display of power. A country showed it could turn a space plane into carry-on luggage. The biggest safe container in the sky. But Mriya's most expensive magic wasn't on its back, it was inside. The An-225 cargo hold is the largest enclosed space ever lifted into the air. Its internal dimensions are about 142 feet long, 21 feet wide, and 14 feet high. Imagine a tunnel longer than the fuselage of a Boeing 737, where a truck can calmly drive in. Total volume is almost 45,900 cubic feet. Inside, you can fit up to 16 standard 40-foot shipping containers, arranged in 2 rows of 8. Why does this matter? Because some cargo in this world is so expensive and so massive that you can't disassemble it, you can't move it by rail, and you can't ship it by sea without unacceptable risk. Generators weighing 150 metric tons. Industrial turbines larger than some houses, emergency humanitarian aid that would otherwise require an entire fleet of conventional aircraft. When someone anywhere said, "We have to move this, and nothing but a miracle will do," they called Antonov and ordered Mriya. How to drive something heavier than a locomotive into an airplane. To load a generator weighing 150 to 200 metric tons, it's not enough to open a door. On the An-225, the entire nose lifts. The huge front section of the fuselage swings up on hydraulic cylinders, as if the plane is yawning. It takes about 10 minutes after external power is connected and the systems are checked. From the ground, it looks like a portal into another world, a black opening roughly 21 by 14 feet, big enough to swallow a small house. But there's still a question. How do you move such heavy cargo inside? The answer is in the floor. Along the full length of the hold run 2 parallel rail tracks. Built into them are rollers, and special trolleys slide along those rollers. And between the rails, hidden in the floor, are thousands of steel balls. Each one spins freely in any direction. Put a turbine weighing close to 150 metric tons on this carpet of balls, and a small miracle happens. Cargo that would require a crane on an ordinary surface can be shifted here with shoulder force. Two loaders brace themselves and literally roll something whose mass surpasses a locomotive. Need to move it a few centimeters left so it doesn't press into a structural frame? You just push. Those balls do their work, and friction nearly disappears. The plane squat, when hydraulics save lives and millions. Another problem is the ramp angle. Driving a 200-ton object up a steep ramp into the aircraft is a recipe for disaster. If the cargo slips back even slightly, no winches will hold that mass. A mistake can cost not only equipment, but human lives. So Mriya has a trick that looks like a big dog lowering its head toward a bowl. The nose landing gear hydraulically squats a bit, while the main gear, on the contrary, extends. The fuselage tilts forward, the floor gets closer to the ground, and the ramp angle drops sharply. Within minutes, the enormous machine becomes effectively lower. The ramp is almost level. Now cargo weighing hundreds of tons can be rolled inside almost straight. No acrobatics, no deadly slopes. When one mistake turns cargo into a rocket. Inside the aircraft, balance is everything. If you simply place cargo wherever it's convenient, the airplane will not forgive you. Every square meter of floor, walls, and ceiling is packed with tie-down points, rated for tens of thousands of pounds, tens of tons of load. Chains, straps, nets, everything is used so that any object, from a container to a turbine, doesn't shift by even a centimeter. The reason is simple. Every aircraft has a center of gravity, the point where all the kilograms meet. Move it too far forward and the nose will pitch down so hard the pilots won't be able to lift it. Move it too far aft and the airplane will pitch up until it stalls. Imagine a 50-ton load sliding across the floor in turbulence. It changes the balance instantly, and what was stable flight becomes an uncontrolled maneuver. That's why loading Mriya was handled by dedicated specialists, load masters. They spent hours calculating weight distribution, double-checking figures multiple times. A mistake here means putting the aircraft, the cargo, and the crew on the line all at once. Maximum internal payload was about 551,000 pounds, roughly 250 metric tons, which is more than the American giant C-5 Galaxy can take, and Mriya could also carry external loads on its back. Originally Buran, but in theory other structures could be mounted on top. In theory, you could load 551,000 pounds inside and add up to 440,000 pounds, around 200 metric tons, outside, but humanity has not yet dared to fly such a mission. The wing that tricks the sound. At speeds around 500 miles per hour, the air starts acting capricious. Even if the aircraft hasn't reached the speed of sound, sections of flow over the wing can locally exceed Mach 1. Small shock waves form there, sharply increasing drag. So that Mriya wouldn't burn extra tons of fuel fighting its own turbulence, the engineers gave it a special wing shape, a so-called supercritical airfoil. Its job is to delay the moment when the airflow over the upper surface begins to break into supersonic behavior, keeping the flow as smooth as possible at a cruising speed of roughly 500 miles per hour. Along the leading edge run slats that extend forward and down during takeoff and landing, increasing the wing's curvature. At the trailing edge are massive Fowler flaps that don't just deflect, they literally grow out of the wing, increasing its area. In simple terms, when it needs to take off or land, the wing inflates, becomes bigger, and grips the air harder. Thanks to this, Mriya can stay airborne at speeds where a clean, unconfigured wing would have long since stalled. Controlling a giant, hydraulics at pressure that can cut steel. Small aircraft can be controlled by muscle. The pilot pulls the yoke, and mechanical linkages move relatively small control surfaces. With the An-225, that's impossible. A single aileron, the surface near the wingtip responsible for roll, reaches more than 26 feet in length. Trying to move it by hand at 800 kilometers per hour is like trying to swing a door open in a hurricane. So everything is driven by hydraulics with a working pressure of about 3,000 pounds per square inch, roughly 207 bar. That's about 100 times higher than the pressure in your car tires. At that pressure, a hydraulic jet can theoretically slice metal if a line fails. To ensure that losing one circuit doesn't cost the aircraft, Mriya uses triple redundancy, 3 independent hydraulic systems. Even if 2 somehow failed, the remaining one would still allow the aircraft to get home. 32 wheels, so it doesn't punch through the runway. At a mass near 640 metric tons, a concrete runway isn't a monolith, it's a fragile resource. If all that weight were concentrated on just a few wheels, Mriya would punch through the runway like a stiletto heel. Pavement would simply crack. The solution? 32 wheels. Of those, 28 are the main wheels, arranged in 2 rows of 7 on each side of the fuselage, and 4 more are at the nose. So the load is spread across such a large area that the ground pressure under Mriya is actually lower than that of some airplanes that are twice as light. For airports, this matters. Not everyone is ready to accept a flying skyscraper and destroy their runway. Each strut is equipped with shock absorbers using nitrogen and hydraulic fluid. When it hits an uneven surface, the strut can compress up to 16 inches, swallowing the impact. That's how Mriya protects not only its cargo, but the fuselage itself, from thousands of small jolts during taxiing, and of course, from the most expensive phase of flight, landing. The legendary flight with Buran. On the 13th of May 1989, Mriya prepares for a flight that will enter textbooks. On its back is the Buran spaceplane, 118 feet long and weighing about 137,000 pounds, roughly 62 metric tons. Together, about 1.23 million pounds, around 558 metric tons of high-tech metal. The airplane accelerates down the runway at the Baikonur Cosmodrome. All 6 engines come up to takeoff thrust. The sound shifts from a howl into a low rumble that makes the ground tremble. The acceleration doesn't feel sharp. When you have hundreds of tons under your wings, even that thrust doesn't create a jerk, but a dense, smooth pressure into your back. At around 100 miles per hour, the wings begin to work. The yoke becomes a bit lighter. The wheels are still rolling on concrete, but the load on them drops with every kilometer per hour of speed. Liftoff happens after about 7,200 feet from the start of the takeoff run, more than 2 kilometers of runway. Then comes a smooth climb, about 1,000 feet per minute. It can't go too high. Buran on top adds aerodynamic drag, so cruising altitude is around 20,000 feet and speed is about 400 miles per hour. That flight, about 2,800 miles with intermediate landings, proved it. Yes, the world now had an airplane that could transport spacecraft like luggage. A day of work for Mriya. Regular missions after the collapse of the Soviet Union looked less cinematic, but no less massive. Antonov crews carried giant gas turbines, generators for power plants, wind turbine components, heavy equipment for emergency situations, and humanitarian cargo. Every such flight began not with takeoff, but with mathematics. First, the cargo weight, then the required amount of fuel, then the runway length at departure and arrival airports. The An-225 needed at least about 10,000 feet of runway at maximum weight. Far from every airport can afford that. Even during climb, the pilots were thinking about landing, what the aircraft's weight would be by the end of the flight, how much fuel would be burned, what approach speed would be needed. At maximum mass, approach speed on the glide path is about 100 miles per hour. The slats and flaps are extended in stages. The wing turns into a giant parachute wing, and the nose rises. Pilots constantly trim. The landing looks like physics being broken. A huge building approaches the concrete at the speed of a passenger car on a highway. First, the 28 main wheels touch. Shock absorbers swallow the transfer of hundreds of tons as weight shifts from wings to gear. A moment later, the nose gear comes down. Now the aircraft can steer and brake more aggressively. 3 systems are used to stop: reverse thrust on all 6 engines, aerodynamic drag from flaps, and wheel brakes with anti-skid. From touchdown to safe taxi speed, a standard runway length of about 6,000 feet is enough. Working in a world of big money and records. After the Soviet Union, Mriya didn't become a museum piece. It became a private contractor in the world of ultra-expensive logistics. Antonov Airlines operated it as a charter heavy lift transport. The list of records is impressive even for people used to expensive toys. The heaviest single cargo item ever lifted into the air, about 247 metric tons. Maximum total payload, about 253.8 metric tons. The longest cargo, about 138 feet in length. In luxury terms, it wasn't an airplane, it was a service. We will deliver your one unique object to a place where no one originally thought it could be delivered. The price of a single contract in missions like these could decide the fate of factories, power grids, and sometimes entire regions. Write in the comments what you think about all this, and subscribe to the channel for the richest. Here, it's all about scale, luxury, wealth, and the lives of the most influential people on the planet. Thanks for watching, and right now, go watch our previous episodes.